Okay, 3.1, pairs of lines and angles. We have a couple essential questions. The first one is, what special angle pairs are formed when two lines are cut by a transversal? This is super important. This is going to keep coming back again and again. And then, what does it mean when two lines are coincident? That's probably a new word for you. Skew, another new word. Parallel or intersecting. Those two should not be new. All right, so let's start with this first little question. We're going to write the number of points of intersection of each pair of coplanar lines. So these are in the same plane. Like, imagine your plane is your piece of paper. So how many points of intersection do parallel lines have? They have none, right? There are 0 points of intersection. How about two intersecting lines? Doesn't mean that they intersect to form any particular angle, but there's just two intersecting lines. Well, they intersect at one point, right? These are lines, so they're never going to turn around and come back and intersect each other again, right? So we've got 1 point of intersection. Now, coincident basically means the exact same line. You got one line on top of the other, so every single point is the same. Okay, so coincident, you can think of that as like the same line or one line on top of the other. And that's going to have infinite, right? Every single point on these lines are basically going to intersect. Okay, so infinite. That's a infinity symbol. To the best of my ability anyways. All right, so I've given you some real world pictures here. So determine if the real world examples show lines that are parallel, perpendicular, or neither. Okay, so railroad tracks. Well, hopefully you know railroad tracks, even though this doesn't look like it in this picture, it looks like they're getting closer and closer together. That's called perspective. Makes pictures look real. These two tracks better be parallel, or else the train is going to have a really hard time getting anywhere, right? Okay, so these right here are parallel. Let's see, I'll write it on top. How about that? I'm going to go down. So these two right here, this is two roads intersecting, right? So this is an example of them intersecting. Now, are they intersecting in just a random point, or are they intersecting to form a 90-degree angle, I guess is the question. We can assume in these ones that this is probably going to be perpendicular. This is usually an intersection where there's like a stop sign maybe at a couple of these spots. Okay, so we're going to say that these are perpendicular, like two streets coming together at an intersection, usually perpendicular. Okay, moving over here. Now, we don't know what this angle is, but I can guarantee it's definitely not a 90-degree angle. So this one's going to be neither. And this last one, notice, like, if you think about these two lines, do they actually ever touch? So think about two street signs, maybe at the corner, at this intersection maybe, okay? These two street signs actually never ever intersect. So if you think about these lines that are kind of drawn on top of them to kind of show you, right, these two lines here never intersect, but they're not parallel. Right, parallel are like two lines in the same plane that never intersect. Look at these. These are like two lines not in the same plane. Okay, so this is a neither. Now this is a very special case, and I'm going to ask you to keep thinking about these road signs as we talk about these. These are actually what we call skew lines. Okay, so how would you describe the two cases above that are neither? Well, this one intersects, right? These do intersect. This one does not intersect, okay? And the reason that these intersect is because they're in the same plane, whereas these two are not in the same plane. So these are not in the same plane. Let's see, I'm just going to write a bunch of notes here. Not in the same plane. Let's see, I should probably do something. I'm going to break these up a little bit. So doesn't intersect, not in the same plane, and we actually call these skew lines. This is a great example of what skew lines are, so I'm going to highlight that. Skew lines, not in the same plane, don't intersect. Okay, so these are different, right? And we kind of listed the ways that they are different. So we know that two lines are parallel lines if they are coplanar and do not intersect. So parallel lines are coplanar, meaning they're in the same plane, and do not intersect. So in this diagram below, we're going to find two lines that are parallel lines, meaning they're in the same plane and they don't intersect. And there's a bunch of them. So for example, line PW and line QX, those two are in the exact same plane, okay, and they also never ever will intersect. You could also do like line QX and line RY. Again, same plane, they're in the side plane here, never going to intersect. You could do line SR, line ZY. Okay, so you can keep doing this over and over. How about I'll go with the top two. So we'll do line PW and line QX. Those are parallel lines. And again, I've named these correctly. I've used 2 points and a line on top. Okay, now what about planes that do not intersect? So planes that don't intersect are called parallel planes. So two planes that don't intersect, parallel planes. So we're looking for two planes that never touch. So if I think about planes again, like the sides of this cube, this top plane and side plane, well, they intersect at line QX. I'm looking for two planes that will never intersect. So maybe you could do like the top plane and the bottom plane, or the right plane and the left plane, maybe the front plane, the back plane. Okay, those are all going to be planes that will never intersect, or pairs of planes that will never intersect. And remember, to name a plane, it's 3 points on the plane. So maybe I'll do the top plane and the bottom plane. So how about PQX? And then the bottom plane, maybe SRY. Those are parallel planes. Now skew lines, as we've talked about before, and I want you to always think about skew lines like those street signs. Okay, they're not in the same plane and they never intersect. Okay, so skew lines are lines that are not coplanar and do not intersect. Not coplanar, do not intersect. So let's find two lines here that are not coplanar and do not intersect. Okay, so let's see. So for example, line QX and line SR, two different planes, right? QX is in either this top plane or the side plane, and SR is on this bottom plane. So they're not in the same plane, they'll never intersect. Okay, those are examples of skew lines. Now you might say to yourself, line PW and line RY, those aren't in the same plane, and therefore will never intersect. However, I can draw a plane, like imagine a slice of paper coming through and being a plane. So, for example, if I connected P to R and W to Y, that is a plane right there that does include both line PW and line RY. Okay, so these actually could be considered parallel lines because they could be considered in the same plane. So those are not skew lines. Okay, so if you can draw a diagram or another plane to include both lines, then they're not going to be skew lines. We could do line PQ and line RY, or PQ and line SZ. Those are all going to be skew lines. Okay, so why don't I do, let's see, I'll choose one more. How about we'll do line WX and line SZ. Oh, that looks pretty bad, but good enough. Okay, so we'll do a little bit more practice with this in class. Okay, so this is going to be done in class. We'll work on this together as part of our assignment. Okay, and we'll do the same thing identifying pairs of angles. We'll also do this in class. Okay. Now we're going to revisit a problem. We're going to revisit number 29 from page 114, section 2.6. And this time we're going to solve this using linear systems. In some of the classes, we went through and we talked about how we had pairs of vertical angles here. And we knew that vertical angles were congruent, right? So 10y and 7x plus 4, those would equal each other. And then 3y plus 11 and 4x minus 22, those would also be congruent, or they would be equal. Their measures would be equal to each other. So what we did instead, we didn't set that up. What we did instead at that time, we didn't review linear systems yet. So we went ahead and we used linear pairs. We said, hey, you know, this angle 4x minus 22 and this angle 7x plus 4, together they form a linear pair, so they formed 180. So we added them together and set them equal to 180. Well, this time we're going to say, no, we know how to do linear systems now. So I can say that this angle is congruent to this angle. Or in other words, they're equal in measure. Okay, so I can write an equation that says, well, 10y is the same as 7x plus 4. And I can do the same thing here. I can say, well, this angle, 3y plus 11, is now the same as 4x minus 22. Okay, so now what we're going to do is we're going to use linear systems to solve this, because notice what we have here. I have this equation has both an x and a y in it, and so does this equation. It has both an x and a y in it. So what we're going to do right now is we're going to solve one of these equations for y, and we'll use substitution to plug it back into the other equation. So let's see, how about if I take this one, let's subtract 11 from both sides. And that will give me 3y equals 4x minus 33. And then I'll divide both sides by 3. So that gives me y equals, now 3 needs to go into both terms here. There are two terms. I'm going to divide 3 into both of them. Okay, so 3 is going to go into 4x, or in other words, that will be 4/3 x. And then negative 33 divided by 3, well, that's negative 11. Okay, so what I'm going to do now is I'm going to take this value for y that I have, and I'm going to substitute it right in, to here, okay, for y. So I'm going to take this value for y, this 4/3 x minus 11, and I'm basically going to plug it in or substitute it in where y is right there. Okay, so that's going to give me 10. Now, instead of putting y there, I'm going to put 4/3 x minus 11. Okay, so now I'm going to distribute my 10 to both terms. So I'm going to get 40 over 3x. I've just done 10 times 4/3 x minus, now 10 times negative 11 is negative 110. It's going to give me 7x plus 4 on the other side. Okay, so now I want to get all my x's on one side and everything else on the other side. So I'm going to add 110 to both sides. So leaving me with 40 over 3x equals 7x plus 114. Now I'll subtract this 7x over to this side. Now, that's the same as 7 over 1x, right? So I can get a common denominator here of 3. Okay, so I'm going to just multiply this one by 3 on top and bottom. So what I really have is I have 40 over 3x. Oops, and I've subtracted that. That's negative 21x over 3. Okay, so on this side, the 7x's go away. I'm going to subtract here. Okay, so I'm going to kind of move everything. Let's see, I didn't leave myself really enough room, so I'm just going to kind of come over here. So 40 minus 21 will be 19 over 3x equals, and then again those 7x's went away and I'm just left with 114. So last step here, I need to get x by itself, and it's being multiplied by 19/3. So I'm going to divide by 19/3, but we don't divide by fractions. Instead, we multiply both sides by the reciprocal, right? So the reciprocal, you just flip 19 over 3. And the reason we do this, let me do that to both sides, and then I'll show you why we do this. See how the 3's, top and bottom, I can divide out 3. Those reduce and just give us 1s. And same with the 19's, right? So I'm just left with 1x over here. So x equals, oh, what's that going to give us? 114 times 3, 342. This is like, think of that over 1, so then 1 times 19. And I think I'm going to use my calculator at this point. So 342 divided by 19. Oh, it's exactly 18. I would have never guessed that. So x is equal to 18. Okay. I have not answered the question, though, because the question was to find the measure of each angle in the diagram. So now that I know what x is, I can go back, how about to here, and figure out what y is. Okay, so I'm going to now take this, and I'm just going to plug this in, substitute that in to figure out what y is. So, oh, I don't even really need to do that, but just to solve the system, I'm going to go ahead and do it for fun. So I'm going to take this and plug it back into here, or substitute it in. So y equals 4/3 times 18 over 1 minus 11. Now, the 4/3 here times the 18 over 1, the 3 and the 18 have a common factor of 3. So I'm going to divide top and bottom by 3. That gives me 1 here and 6 here. So y is really going to be 24 minus 11, or 13. Okay, still haven't answered the question. I need to go back here and figure out what each angle is. Okay, so one way to check this is to make sure that everything is giving me what it should be giving me. So for example, 10 times 13 here would be 130 degrees. Well, if I do the same thing here and I put 7 times 18 plus 4, I better get 130 degrees. So 7 times 18, and then I'll add 4 to that, 130. So my x and my y are correct. And now I can just do that for one of these, and they're going to be exactly the same. So how about 3 times 13, that's 39, plus 11, that's going to give me 50, which makes sense because 50 plus 130, that's a linear pair. That will give me 180. Okay, so this is going to be 50 degrees, and this one's also going to be 50 degrees. All right, let's do a couple examples here from your textbook. So, example 1, identifying lines and planes. Think of each segment in the figure as part of a line. Which line, lines, or plane, planes appear to fit the description? All right. So for A, we need lines that are parallel to line GH containing point F. So line GH is here. And I need a line or lines that are parallel to that line containing point F. Well, it looks to me like this line over here, parallel means in the same plane, right? So I need something that contains point F and is a line that is parallel to this one. So I think it's going to be line EF. So let's see. I'm just going to answer down here, A. Line EF. Or line FE. You could have named it either way. Either way would totally work. Okay, moving on. Let's do B. So I want line or lines that are skewed to line GH and containing point F. Okay, so here's line GH. We want something that's in a different plane containing F. So it looks like I could do line BF here. So let's see, let's go here. So we'll do line BF. But I don't think that's the only one. What about line CF? See how that's also never going to touch line GH and is not in the same plane as line GH? So we could do line CF. What about line AF? Right? So again, here's line GH. AF is not in the same plane, right? So it's not going to be parallel. It's completely skew. How about F to D, right? Line FD here is not in the same plane as line GH. Okay, I can think of any plane that I could draw containing line GH and line FD. Okay, so this is also going to be skew. I think that's it. All right, now we want a line or lines perpendicular to line GH and containing point F. Well, I think there's only going to be one of those, right? It's going to be this line right here. It needs to be, again, that line's going to have to be in the same plane as GF in order to be touching it, right? So FG, I think, is the line that is in the exact same plane as HG and would form a right angle here. Imagine that this is a rectangular prism. Okay. I don't think they did a good job of explaining that, but all right, and then we're going to look for a plane or planes that are parallel to plane GHD. Let's see. GHD. So this plane here and containing point F. Well, I think that you're going to have this plane over here that is parallel to this plane. They're never ever going to touch. Again, thinking that this is a rectangular prism. So how about we say plane, and I'm just going to pick any 3 points in this plane. So how about AFE? Okay, we have a couple postulates down here. Again, postulates being things that are just accepted as true. All right, so the parallel postulate. If there is a line and a point not on that line, okay, so I have line L here and I have a point not on that line, okay, then there is exactly one line through the point, through point P, that will also be parallel to the given line. In other words, here's point P, pretend like that line's not drawn, okay, and I've got this line, and I'm looking to draw some line that is parallel through point P that's parallel to line L. Okay, well, I can only do this one way. There's only going to be one line through here that's going to be parallel to line L. Right? Think about it. If I do it any other way, if I'm, sitting here trying to draw any other line, those aren't going to be parallel. Okay? That's all that this is saying. So given a point and a line, there's only going to be one line through that point that's going to be parallel to the line that you've been given. So the parallel postulate says there's a line and a point not on the line. There's exactly one line through the point that's parallel to the given line. Okay, and then, and we know that they're parallel because of these little arrows. Those arrows tell me that those two lines are parallel. Okay, next, perpendicular postulate. Very similar. So if there's a line and a point not on the line L, point P, then there is exactly one line through the point perpendicular to the given line. You can only make one line through this point P that's going to be perpendicular to line L. Okay, and we know that it's perpendicular because of this little right angle. Okay, so that's all that that's saying. And we'll come up with equations of lines. Okay, so if you're given a line and you are given a point not on that line, you're going to have to come up with the equation of this line. And same thing here, okay, perpendicular. And that goes back to slopes, right? So parallel lines have the same slope, perpendicular lines have opposite reciprocal slopes. All right, identifying parallel and perpendicular lines. Okay, so the given line markings show how the roads in a town are related to each other. So I can see that there are some arrows here. It's kind of a little bit blurry, but there are some arrows here. Let's see, what else are there? There's a right angle there. Okay, so we're going to name a pair of parallel lines. So we're looking for the little arrows that show us that two lines are parallel. So what I can see here, like I pointed out, were that these two had two little arrows. That shows that they are parallel to one another. Okay, so we can say that line HL is parallel to line GK. Oh, that reminds me, I think I skipped something. I think I skipped this notation. Let's go back to the back of the first page. Symbolic form, I forgot to do that. Okay, so when two lines are parallel, like line PW and line QX, you don't have to write like that they're parallel. You can actually use a symbol for parallel. And that symbol looks like this, like what we just did. So line PW is parallel to line QX. Okay, that's symbolic form. This right here is symbolic form, meaning you're using a symbol to represent them being parallel. And we can do that with perpendicular lines too. Okay, so let's go back. I think we've already done that one in class. So that's symbolic form for parallel. Okay, now we'll name a pair of perpendicular lines. Well, we know that this little right angle here shows us that two lines are perpendicular. So I could do, how about line GK and line JL. So line GK is perpendicular, so that's the perpendicular symbol. What did I say to line JL? Okay, so these are symbolic forms. It's a lot easier than writing line HL is parallel to line GK. Just use the little symbols. All right, and then the last question here for C is line, is that a line or a segment? I don't know. I think it's lines. So we're going to say that it's lines. Is line GN, so I'm going to put little arrows there to make it really obvious. Is line GN perpendicular to line JL? Okay, so line GN perpendicular to line GL. Well, I already said that GK, line GK was perpendicular to line JL. And how many lines can be perpendicular that going through point G? How many lines through point G can be perpendicular to line JL? Well, really only one, right? That was that perpendicular postulate. Okay, so it doesn't make any sense for GN, line GN, to also be perpendicular to JL. Okay, so I'm going to say no. Only one line can go through G and be perpendicular to line JL. And that line that is going through G and is perpendicular to line JL was line GK. All right. Moving on, let's talk about transversals. All right, so a transversal is a line that intersects two or more coplanar lines at different points. Okay, so once again, a transversal is a line that intersects two or more coplanar lines at different points. So over here, you can see I've labeled this transversal. This line right here, that's our transversal, right? It's intersecting lines L and M, okay, which are coplanar lines. Okay. So what we're going to do now is we're going to actually redraw this diagram, okay, with our own two lines here. All right, so we're going to draw a transversal below. We're going to label the top line as M, the bottom as N, and the transversal as P. All right, so I'm going to get my ruler. Let's see, where's my ruler? All right, so top line is M, bottom line is N, the transversal is P. We're going to next label each angle like the diagram above. So 1, 2, 3, 4. 1, 2, 3, 4, 5, 6, 7, 8. 5, 6, 7, 8. Okay, and then we're going to answer the questions below to identify some special angles. All right, so the most important thing that we're going to want to do is we're going to want to explain how each of the angles are related. And we'll use this example to help us. So number 1, if we look at angle 1 and angle 7. Okay, let's see what the answer is. How are angle 1 and angle 7 related to each other? Both of these angles are outside the lines M and N, right? They're both outside. If you think of this as the outside and this is the inside, okay? They're both outside the lines M and N and are on opposite sides of the transversal, right? Opposite sides. So 1's on the left side of the transversal, 7's on the right side of the transversal. So that's how we want to think about these as we're going through and doing these. So when we look at like 4 and 6, well, they're both inside lines M and N, right? So they're on the inside of lines M and N. But they're on opposite sides of the transversal, right? So I'm going to put on opposite sides of transversal, which is P, line P. All right, let's look at 4 and 5. Well, 4 and 5 are both, again, inside lines M and N. So they're on the inside of lines M and N. But how do they relate to the transversal? Well, they're on the same side of the transversal, right? They're both on the left side of the transversal. So on same side of transversal. Okay, let's look at 2 and 6. So 2 and 6, well, they're both on top of lines M and N. So they're not necessarily both on the outside or on the inside. They're both on top of those two lines M and N, right? So they're on top of lines M and N. Oops. M&Ms, yum. Okay, but how do they relate to the transversal? Well, they're on the same side as the transversal, right? Okay, so same side as the transversal. All right, what have I missed? 3 and 7. I think we're okay with that. Okay, so let's see what else we've got here. So what other angles have the same relationship as each of the pairs of angles above. Okay, so let's go back through this. So 4 and 6, they're on the inside of the lines M and N on opposite sides of the transversal. So what other pair of angles are both on the inside of M and N and on opposite sides of the transversal? Well, 3 and 5, right? Okay, so this one's going to be 3 and 5. Angle 3 and angle 5. Oh, let's do number 1 too. We didn't do that. So 1 and 7, both on the outside of lines M and N and on opposite sides of the transversal. So on the outside and on opposite sides. So what are the other ones? The other pair of angles? Hopefully you see that it's angle 2 and angle 8. Okay, 4 and 5, they're both on the inside of lines M and N and on the same side of the transversal. So what's another pair of angles that are both on the inside and on the same side of the transversal? 3 and 6. Okay, and then angles 2 and angle 6. Let's see, so they were on top of lines M and N, on top, so in the same position with relation to those two lines, and they were also on the same side of the transversal. Okay, so I think 1 and 5 would be another pair of angles in a similar position. But actually, you have several of these, so not just that they're on top. What if they're on the bottom of each respective line and on the same side of the transversal? So like angles 4 and 8, 3 and 7, both on the bottom of their respective line, M and N, and on the same side of the transversal. So I'm also going to go with angle 4 and angle 8 and angles 3 and 7. Even though these ones are not on top, these ones are on bottom of lines M and N, but they are on the same side of the transversal. Okay, now each one of these angle pairs have a special name. Okay, so let's talk about these. They are right here. So here they are. These are all the angles formed by the transversals. Notice that there are 4 different types, and there were 4 different types here. These are special angle pairs. Okay. And these become very important, so make sure you got these. Okay, first ones are corresponding angles. So 2 angles are corresponding when they have corresponding positions, meaning, for example, angles 2 and angle 6 are both above the lines and to the right of the transversal. So they're both on top of the lines and on the same side of the transversal. Okay, so our examples here, which one of these are corresponding angles? Meaning that they're both on top or on bottom, so in the same position with respect to their lines, M and N, and then they're on the same side of the transversal. Okay, well, this one's one on the same side, but these are inside of the lines, right? So these are not like in the same position, in corresponding positions. These are both on top of the lines or on the bottom of the lines and on the same side of the transversal. So these would be your corresponding angles. Okay, so the specific name that we call these is corresponding angles. So these are examples of corresponding angles. And again, their relationship is that they are basically the 2 lines being cut by the transversal. Those corresponding angles are either both going to be on the top and on the same side of the transversal, or they'll both be on the bottom, like 3 and 7, and on the same side of the transversal. Okay, those are corresponding angles. Let's go alternate interior angles. So alternate interior angles lie between the lines and on opposite sides of the transversal. So they lie between the lines or on the inside of the two lines and on the opposite sides of the transversal. Okay, so alternate interior, between the lines, opposite sides of the transversal. Inside the lines, opposite sides of the transversal. So 4 and 6, 5 and 3, those were alternate interior. So where were those? 4 and 6 and 3 and 5. So these will be our alternate interior. Okay, next, alternate exterior. So alternate exterior angles lie outside the two lines and on opposite sides of the transversal. Right? They alternate on opposite sides of the transversal. So they lie outside the two lines on opposite sides of the transversal. So like 1 and 7 and 2 and 8. So these right here are our alternate exterior. Okay, and the last type are consecutive interior angles. Consecutive interior angles lie between the two lines or on the inside and on the same side of the transversal. So inside and on the same side is consecutive interior. So for example, in this example we had, right, they're both on the inside and on the same side of the transversal. So these are consecutive interior, 4 and 5 and 3 and 6. Okay, so you guys need to really learn these. Let's see. I don't really have, these are just in corresponding positions. So I think I'll just say have corresponding positions. You guys really need to learn these definitions, okay? So let's do a couple of these and we'll be done. Okay, identify all pairs of angles of the given type. So consecutive interior, basically, so first of all, let's identify what's my transversal. I've got two lines here being cut by a third line. So this is going to be my transversal. So it might be helpful, you know, because all of these have the two lines and then the transversal was going up and down. It might be helpful to look at it like this. Okay, so consecutive interior, again, if you want to read the definition here, they lie between the two lines and on the same side of the transversal. So between the two lines are like 8 and 7, same side, and 3 and 4. So angle 8 and angle 7, and then angle 3 and angle 4. Okay, let's do alternate exterior. So, let's look at the definition first. They lie outside the two lines and on opposite sides of the transversal. So here's my two lines. They've got to go outside. So I'm looking over here. And on opposite sides of the transversal. So you got 1 and 5 and 2 and 6. Corresponding, remember those were in corresponding positions. So like both on top and on the same side. Or both on the bottom and on the same side. Okay, so both on top and on the same side is going to be 1 and 7 and 2 and 4. Those were just on the top though. What about on the bottom? So on the bottom you've got 3 and 5 and 8 and 6. Okay, and then the last one is alternate interior. Okay, so looking at these, well, actually, we should probably look at the definition first. Alternate interior lie between or on the inside of the two lines and on opposite sides of the transversal. So looking at inside, so 8, 7, 3, and 4, but on opposite sides of the transversal. So that's going to be 3 and 7 and 8 and 4. So angle 3 and angle 7, angle 8 and angle 4.